The year is 278 million BC. The Earth trembles with an earth-shattering roar. A plume of ash and gas erupts into the atmosphere, blocking out the sun and heralding a volcanic winter that will entomb the Earth in ice. At least that's what Hollywood would have you believe about supervolcanoes. But are these giant, ticking time bombs really the Earth-killing machines the movies make them out to be? Or are they just another case of scientific sensationalism? Let's take a closer look at these giants of the geologic world and bust some myths along the way. It all starts with the definition. What is a supervolcano? It's not the size of the volcano that matters, but how much you can blow it up. According to the U.S. Geological Survey, a supervolcano is any volcano that has had an eruption magnitude of 8 on the Volcanic Explosivity Index, or VEI. An eruption of magnitude 8 is defined as an eruption that deposits more than 1,000 cubic kilometers of material and creates a caldera more than 100 kilometers across. To put that into perspective, this much volume of material could fill up nearly 400,000 Olympic swimming pools, or completely bury Manhattan under 3 meters of ash. And instead of the 100-kilometer caldera, we'd need something over 500 kilometers wide to fit our gigantic Empire State Building into. And that's one heck of an explosion. But that doesn't mean a supervolcano is necessarily visible from space, though that depends on your eyesight. Yellowstone National Park's supervolcano is approximately 43 by 65 miles across, so it wouldn't be easy to miss even without binoculars. Of course, you can't actually see anything through a telescope either, because even though the top of the Earth's atmosphere ends around 100 kilometers above sea level, most telescopes can't resolve objects smaller than about 300 feet across, which is small compared to a volcano, but if you had eyes like a hawk, you might be able to spot it. Yellowstone is one of only 12 supervolcanoes known to exist on Earth, with 8 located in the US alone. We can find supervolcanoes in places you wouldn't expect, like under the ocean off the coast of the Florida Peninsula and the island of Sicily in Italy, home to Mount Etna, Europe's tallest active volcano. Although we have only confirmed 12 supervolcanoes so far, scientists estimate that there could be many more, including several hidden deep within the oceans where they can go unnoticed for millennia. But unlike their more famous cousins, the stratovolcanoes, supervolcanoes don't always live up to their name. They aren't always super active. In fact, 8 out of the 12 known supervolcanoes haven't erupted in over 1 million years. Stratovolcanoes like Mount Fuji in Japan and Mount Vesuvius near Naples, Italy, have been infamous for their regular violent eruptions throughout recorded history. But supervolcanoes generally follow their own schedule, often going thousands of years between eruptions, sometimes hundreds of thousands of years. It's hard to say exactly why some supervolcanoes erupt regularly while others seem to sleep forever. It could have something to do with the magma chambers beneath each volcano. Scientists think that the magma chambers under supervolcanoes may be connected to the mantle, allowing new magma to continually flow in and replace what was lost during an eruption. Under normal volcanoes, on the other hand, magma chambers are isolated pockets in the crust that once the magma chamber is empty, it's empty. There's no backflow to replenish it. But supervolcanoes' quiet nature is part of what makes them such a good candidate for a doomsday device. You see, when people think supervolcano, they're usually thinking Yellowstone. And the idea of Yellowstone erupting has become such a popular trope in disaster movies that you probably don't even notice it anymore. This is despite the fact that the chances of Yellowstone erupting tomorrow are about 1 in 730,000. But it isn't just Hollywood that gets caught up in Yellowstone fever. Researchers have been studying the park's supervolcano ever since the United States Geological Survey started monitoring it in the early 1980s. Despite billions of dollars spent and countless papers published, scientists still don't know exactly how, why, or when Yellowstone will erupt again. We do know that it last erupted around 640,000 years ago, but before that, it had its first go at superhood around 2 million years ago. But the idea of a catastrophic super eruption is relatively new to the public consciousness. In 1985, a paper published by 2 geologists proposed that Yellowstone's previous eruptions were actually 2 super eruptions separated by a period of normal activity. Then, in 1995, a paper suggested that the entire history of Yellowstone's magma system was punctuated by 3 super eruptions at irregular intervals. But the idea really took off when a geologist published a paper suggesting that the next super eruption at Yellowstone could happen within our lifetimes. The media picked up the story and soon everyone was talking about the end of days. But let's think about this logically. If the average time between super eruptions is 600,000 years, then we should be due for one right about now. Unfortunately, statistics don't work like that. Just because something happens every 600,000 years doesn't mean that it will happen now or in 6,000 years. It means that we have no idea when it will happen next. And unfortunately, science doesn't have a better answer than that. Some researchers believe that the interval between eruptions may be lengthening rather than shortening. This theory is based on the age of the Yellowstone's lava flows. The youngest is 7,000 years old, so the next eruption could be thousands of years away or it could be millions. Sometime in the next few million years, the Yellowstone supervolcano will erupt. It's just impossible to tell when, and it won't be the end of the world. Movies would have you believe that life would end if Yellowstone were to erupt today. But let's look at some previous eruptions for clues. The most recent eruption of Mount Pinatubo in the Philippines occurred in 1991. It was one of the largest eruptions of the 20th century. Ash descended on Manila, a city of 1.2 million people. Over 800 people died in the eruption, and thousands more were injured. But a study published in 1999 estimated that overall, Mount Pinatubo had a positive impact on the global economy. Crops in the Philippines were devastated, but crop losses elsewhere were offset by increased carbon dioxide uptake after the eruption. The rest of the world saw a cooling effect as well, with temperatures dropping 0.5 degrees Celsius below normal for about 2 years afterward. But worldwide food production actually increased by almost 5% after the Mount Pinatubo eruption. The reason, according to the study, is that while the northern hemisphere was experiencing winter, which saw reduced crop yields, the eruption occurred during the spring in the southern hemisphere. When crops there were in full swing, the net result was higher yields. So what about a truly super eruption? After all, Mount St. Helens in Washington state erupted with a force of 5 on the VEI scale. That's 5 times less than what it would take to make it a super eruption. The 1980 eruption killed 57 people, caused an estimated $1.2 billion in damage, and sent ash as far away as Canada and Mexico. But the rest of the world didn't feel a thing. This was enough to inspire a whole movie called St. Helens, Perfect Volcano. But it wasn't enough to kill anyone outside of the Pacific Northwest. Now imagine this. A supervolcano eruption does send massive amounts of ash and gas into the atmosphere. But even if enough particles get high enough into the stratosphere to block sunlight, there's still the rest of the atmosphere to consider. Ultraviolet radiation from the sun filters through the ozone layer in the stratosphere and reaches the surface. Infrared radiation from the sun passes through the troposphere, the lowest layer of the atmosphere, and is absorbed by water vapor, carbon dioxide, and ozone, heating the lower atmosphere. Even if the upper atmosphere cools, the lower atmosphere would still heat up. But let's say the apocalypse is averted and the world goes on as usual. If you lived through the eruption, you'd still have to deal with the aftermath. Unlike stratovolcanoes, which have steep conical shapes, supervolcanoes tend to have flat, wide profiles because their magma chambers are so vast. And when they erupt, they tend to blow all the way through the top of the volcano, leaving behind a large crater that's much larger than the volcano itself. And we're talking really big here. Yellowstone's supervolcano has formed 3 calderas, which are the craters left behind after the collapse of a volcano's summit. The largest of these is 43 by 28 miles. But this doesn't mean that Yellowstone will suddenly collapse into itself, dooming the nearby towns of West Yellowstone and Gardner, Montana. Calderas form when a volcano loses its structural support. It's unlikely that these towns would be affected unless the ground underneath them also started to collapse, which seems very unlikely. Calderas can also be filled in by normal geological processes over time. So even if they did sink, the towns of West Yellowstone and Gardner, Montana would still be safe. If Yellowstone erupted tomorrow, the nearby states of Idaho, Wyoming, and Montana would be covered in ash and toxic gases. But the surrounding areas would be habitable again within weeks, and the rest of the country would just have to deal with a bit of extra ash in the air. So despite what the movies would have you believe, a supervolcanic eruption won't automatically kill everyone on Earth. The real danger lies in the amount of sulfur dioxide gas released into the atmosphere. Sulfur dioxide gas reacts with water and oxygen in the atmosphere to produce sulfuric acid. Sulfuric acid aerosols reflect light and heat away from the Earth, lowering temperatures around the world. After the 1815 eruption of Mount Tambora in Indonesia, which had a VEI rating of 7, temperatures around the world dropped by 3 degrees Celsius. This caused widespread crop failure and famine, killing an estimated 88,000 people. So while a supervolcano eruption may not kill everyone immediately, it could lead to a long and slow death for many. When it comes to predicting how destructive a volcano will be, it's not just the height of the eruption or the amount of sulfur dioxide released that matters. It's the explosivity index that counts. And the explosivity index is calculated by taking the logarithm of the volume of the eruption and subtracting the square root of the surface area of the crater it created. With a little bit of math, we can calculate the VEI, which takes into account both the size of the eruption and the structural integrity of the volcano, meaning that not all supereruptions are the same. Eruptions that have the same magnitude on the VEI scale don't necessarily release the same amount of sulfur dioxide gas or produce the same amount of ash. For example, in 1596, the Unzen and Ira formed on the Japanese island of Kyushu with a VEI of 6. Both were massive eruptions that deposited tons of pyroclastic flow and ash on the island. However, the amount of ash fell off dramatically after a few hundred miles, with pumice and ash being found as far away as Korea, China, and the Mariana Islands, 2,000 kilometers away. But that's nothing compared to Mount St. Helens, which had a VEI of 5. Its eruption in 1980 sent ash as far away as Canada and Mexico. It was the deadliest eruption in U.S. history, killing 57 people. All of these events had different magnitudes on the VEI scale. So it's important to remember that size doesn't matter, it's how you use it that counts. Now watch. Yellowstone supervolcano, biggest eruption in history, or check out Supervolcano Doomsday device.